Intricate Devo, intricate.
Hello everyone, and welcome back to Intricate Devo, the channel where complex programming concepts become simple, practical, and fun to learn. Today we are diving into one of the most important concepts in Java and object-oriented programming. If you've ever wondered how completely different classes can follow the same set of rules while behaving differently, then today's lesson is for you. We're talking about Java interfaces. But before we begin, I have a quick challenge for you. If you're serious about becoming a Java developer and mastering object-oriented programming, hit that subscribe button right now and join the Intricate Devo learning community also. Smash that like button because it helps this video reach more learners who are struggling with Java concepts. And if you know someone who's learning Java, don't forget to share this video with them. Done? Awesome. Let's get started. Think of an interface as a contract or a rulebook. It contains method declarations without implementation. For example, interface animal, void animal sound, void sleep. This interface tells every animal, you must know how to make a sound, you must know how to sleep. But it doesn't explain HOW. That's the recipient of the class that implements the interface. Now let's create a pig class. Class pig implements animal. Public void animal sound. System.out.println. The pig says, wee. Public void sleep. System.out.println. Zezis. Notice the keyword. Implements, not extends. Because interfaces are implemented, not extended. The pig class agrees to follow the animal contract. Java checks. Animal requires two methods. Did pig implement both methods? If the answer is no, compilation error. Java won't allow the class to exist until it fulfills the contract. Pig myPig equals new pig. My pig.animal sound. My pig.sleep. Output. The pig says wee. Z's. Simple. The interface defined the rules. The pig provided the implementation. Now you might be thinking, okay, this works. But why do we need interfaces at all? Great question. Let's look at the three biggest reasons. Interfaces help us hide implementation details. Users only see the actions available. Think about driving a car. You press the accelerator. The car moves. You press the brake. The car stops. You don't need to understand the engine fuel injection system or transmission. You only care about using the functionality. Interfaces work the same way. They expose what can be done without revealing how it's done. This is one of the biggest advantages of interfaces. A Java class can extend only one class. For example, class dog extends animal, that's allowed. But Java does not allow. Class dog extends animal machine. Not allowed. However, Java allows multiple interfaces. Class robot dog implements animal machine. Now the class can behave like both. This gives Java the benefits of multiple inheritance without many of the problems. This sounds complicated, but it's actually simple. Imagine hiring a driver. You only care that they can drive. You don't care whether they drive a Honda, Tesla, BMW, or Ferrari, as long as they follow the driving contract. Similarly, your code can depend on an interface instead of a specific implementation. Later, you can replace the implementation without changing the rest of your code. That's called loose coupling. And it's one of the reasons professional software remains flexible and maintainable. Before we continue, tell me in the comments, can you think of a real-world example of an interface? Maybe something that defines a set of rules but doesn't care how those rules are implemented? Pause the video and leave your answer below. I love reading your examples because they show how you're connecting programming concepts to the real world. Let's see multiple interfaces in action. Interface first interface. Void my method. Interface second interface. Void my method. Now implement both. Class demo class implements first interface, second interface. Public void my method. System.out.println. Some text. Public void my method. System.out.println. Some other text. Notice this line. Implements first interface, second interface. One class. Multiple contracts. That's Java's way of supporting multiple inheritance. These points are extremely important for interviews. Interfaces cannot create objects. Animal equals new animal. Not allowed. Interface methods traditionally have no body. Interface methods are automatically public abstract. Even if you don't write those keywords. Interface variables are automatically public static final, which means they are constants. Interfaces cannot have constructors because interfaces themselves cannot be instantiated. Historically, interfaces were very limited, but Java evolved and interfaces became much more powerful. Let's look at the modern features. Java 8 introduced default methods. These methods already contain implementation. Example: default void stop. System.out.println vehicle is stopping. Every implementing class automatically gets this behavior. No need to rewrite it. This was a huge improvement because it allowed developers to update interfaces without breaking existing code. Java 8 also introduced static methods. Example: static void service. System.out.println performing standard vehicle service. Call it like this: vehicle service. Notice that no object is required. The method belongs directly to the interface. Java 9 introduced private methods. These methods help reduce code duplication inside interfaces. Example: private void log action, string action. Only methods within the interface can use it. Implementing classes cannot access it. Think of it as a helper method hidden behind the scenes. Imagine a vehicle interface. Interface vehicle. Void start. Now different classes implement it. Car. Car starts with a key bike. Bike starts with a button truck. Truck starts with a heavy-duty ignition. Different implementations. Same contract. That's the beauty of interfaces. Quick favor. If this explanation is helping you understand Java interfaces better than before, hit the like button. It takes just 1 second but helps the channel tremendously. And if you're new here, subscribe now because we are covering Java from beginner level all the way to advanced concepts, including interview preparation and real-world projects. Now for one of our most common Java interview questions. When should you use an abstract class and when should you use an interface? Let's make it easy. Abstract class: use an abstract class when classes share an identity. Example: dog is an animal. Cat is an animal. Lion is an animal. They belong to the same family. Use an interface when classes share a capability. Example: bird can fly. Airplane can fly. Drone can fly. They're completely different things. But they share one capability: flying. That's the perfect job for an interface. Here's a trick you'll never forget. Abstract class equals is a relationship. Dog is a animal. Car is a vehicle. Interface equals Kandu relationship. Bird can fly. Robot can fly. Airplane can fly. Remember this and you'll answer many interview questions correctly. Today we learned what an interface is, why interfaces exist, total abstraction, multiple inheritance, loose coupling, important interface rules, default methods, static methods, private methods, abstract class versus interface, real-world examples. And that's Java interfaces explained simply. If abstract classes describe what something is, interfaces describe what something can do. Mastering interfaces is a huge step toward becoming a professional Java developer, because you'll see them everywhere from Java collections to Spring Boot, enterprise applications, and large-scale software systems. If today's video helped you, please hit the like button, subscribe to Intricate Devo for more Java tutorials, coding tips, interview preparation, and real-world programming concepts. Share this video with your friends, classmates, and colleagues who are learning Java. And now I have one final challenge for you. Comment below. When would you choose an interface instead of an abstract class? I'll be reading comments and responded to some of the best answers. Thank you for being part of the Intricate Devo community. Keep learning, keep building, keep practicing, and keep coding. I'll see you in the next video.